Alrighty, so let's talk about the mole, M-O-L-E. Before we do that though, you have to have a periodic table in front of you. So go ahead and pause the video right now, the tutorial, pause me, and go ahead and get a periodic table ready. If you don't have one, you can just watch with this one, but make sure you have a periodic table ready for this. So let's talk about the mole, M-O-L-E. Let's get my pen going. Here we go. So the mole, right? So if you have a mole of something, that just means that you have 6.022 times 10 to the 23rd of that substance, which is a lot. If you had a mole of cars, you'd have 6.022 times 10 to the 23rd cars. If you had a mole of pencils, you'd have 6.022 times 10 to the 23rd pencils. And to give you an idea of how big that number is, if you had a mole of pieces of paper like stacked, you'd have 2 stacks from here to the moon. So that's a huge number. To give you a perspective why we need it in chemistry, it's because atoms and molecules are so small. For example, if you had 6.022 times 10 to the 23rd water molecules, just this, like just H2O, if you just had 6.022, 602 sextillion water molecules, it would fit in a normal sized glass and it would be about a gulp of water. That's how small water molecules are. So we need to work in big numbers because you can't just work with one water molecule. You have to work with many of them. So when you're looking at the periodic table, what's cool about the periodic table is these numbers right here, the atomic masses. Like for example, lithium right here, right, number 3, has an atomic weight or mass of 6.94. So what that's telling you is that 1 mole of lithium atoms, so if you had a mole of lithium atoms, they would weigh 6.94 grams. So if you count it out, 602 sextillion, 6.022 times 10 to the 23rd atoms of lithium, that's a lot of lithium atoms, and weighed them, it would weigh 6.94 grams. Now you can't count out that many atoms, but you can take lithium. If you had a jar of lithium, you could take it and weigh it. You could put it on a balance and weigh out 6.94 grams, and when you did, you would know that you had 6.022 times 10 to the 23rd atoms of lithium. Another example would be carbon over here, number 6, right? Carbon is number 6 on the periodic table. Not boron, carbon. 12.01 is the atomic mass, so that means if you had carbon, and you can get carbon. Carbon is like charcoal, right? Or the charcoal sketch sticks that artists use. So if you weighed out 12.01 grams of those charcoal sketch tools, and you put them on a balance or a scale, and you weighed out 12 grams, you would have a mole of carbon, which means that you would have 6.022 times 10 to the 23rd atoms of carbon. Okay, so the numbers on the periodic table are important. Let's use chlorine for example, atomic number 17 over here, right? 35.45 is the atomic mass. So if I have 1 mole of chlorine, that means I have 6.022 times 10 to the 23rd atoms of chlorine, and I know from the periodic table right here that many chlorine atoms is going to weigh 35.45 grams. If we use, I don't know, uranium right here, number 92, right? If I have 1 mole of uranium, that means I have 6.022 times 10 to the 23rd atoms of uranium, which means if I counted them out and put them on a scale, it would weigh 238.03 grams. Now you can't count out atoms of uranium, but you can weigh uranium. So if you take chunks of uranium and you keep putting chunks on the balance, and when the balance gets to 238.03, you know that you literally have in front of you 6.02 2 times 10 to the 23rd atoms of uranium, which means you're holding on to a mole of uranium. Now, I don't want you to actually hold a mole of uranium because it is radioactive, but you get the point. Now, sometimes you don't work with full moles, right? Sometimes you might have 2 moles of something. Well, if you have 2 moles of something, it's just 2 times 6.022 times 10 to the 23rd on your calculator. And so if you did that on your calculator, let me grab my calculator, you get 1.204 times 10 to the 24th. Again, you're not always going to work with 1 mole. Let's say you're working with a half a mole, 0.5 moles. Right? Everywhere you see the word mole, just plug in 6.022 times 10 to the 23rd and multiply it. So it's 0.5 times the word mole, so 6.022 times 10 to the 23rd. And if you do that math, you get 3.011 times 10 to the 23rd. Don't let the 6.022 times 10 to the 23rd scare you. It's just a number. That's all it is. You're not always going to work with such nice numbers. Maybe you need 0.67 moles of some substance, right? So 0.67 moles would be 0.67 times 6.022 times 10 to the 23rd, in which case you would get 4.035 times 10 to the 23rd. Now, I'm going to go back and look at my sig figs, right? This number only has 1 significant digit, so technically my answer can only have 1. So I would end up with 3 times 10 to the 23rd. And this number has 2 significant digits, so technically my answer can only have 2, so I would end up with 4.0 times 10 to the 23rd as my answer there. So that's how you convert particles. So if I had 2 moles of maybe oxygen atoms, that means I'd have 1.204 times 10 to the 24th atoms. Or if I had a half a mole of sodium chloride formula units, that means I'd have 3 times 10 to the 23rd formula units of sodium chloride. Or if I had 0.67 moles of whatever, carbon atoms, that means I'd have 4.0 times 10 to the 23rd atoms of carbon. So the next thing you can do is work in to all of that, how much something weighs, right? The mass of something. So let's say I have 1 mole of carbon atoms. We'll just go with that. 1 mole of carbon atoms. That means I have 6.022 times 10 to the 23rd carbon atoms. But how much does that weigh, right? What's the mass in grams? Well, we know from the periodic table, if we're dealing with 1 mole of a substance, I can get the mass right from the periodic table. And we know carbon right here weighs 12.01 grams. So we're going to put that right there. So carbon weighs 12.01 grams if you have a mole of it. But if you have 2 moles of carbon atoms, you're not going to have 12.01 grams, right? You're going to have 24.02 grams. Or if you had a half a mole of carbon atoms, instead of having 12 grams, you'd have about 6 grams of carbon. Okay, so it's the same idea. Everywhere you see the word mole, you're just equating that to the mass of on the periodic table. So again, if I had 0.34 moles of carbon, how many grams is that? Well, that math you can't really do in your head, probably, right? So you could set up a proportion, like a ratio. So you could do something like if 1 mole, actually we wouldn't put moles on top because we're trying to get to grams. If 1 mole of carbon weighs 12.01 grams, let me erase this. There we go. if 1 mole weighs 12.01 grams, then how many grams does 0.34 moles weigh, right? You could set up a proportion or a ratio, and then you can just cross multiply and divide to find x. So you could do the 0.34 times 12 on your calculator, and then divide by the 1, because right, you're cross multiplying and dividing. So 0.34 times 12 divided by the 1, and you would end up with x equals 4.08 grams of carbon. Now, one last thing, I probably would not report this as 4.08. I'd probably report it as 4.1 because of significant digits. So the 8 here rounds that 0 up to a 1 grams of carbon, because my original number only has 2 sig figs. So my answer can actually only have 2 sig figs.